Hello everyone, welcome back to part 3 of this video series Learn Hadoop. Today we are going to write our code for word count problem in Java and run it on the single node cluster setup on our local machine. Now in my previous video I explained in details with example about how Hadoop MapReduce will work for this problem. If you haven't watched that video, I would suggest that you watch that video and then come back to this video. That will make it easy for you to understand when you are coding. Now I am using Ubuntu. You may use any Linux operating system of your preference, but make sure that you have both Java and Hadoop installed and set up on your machine. If you don't have Hadoop Single Node Cluster set up, then watch the first video of this series where I did a step-by-step walkthrough of the entire installation and setup process. If you have a different version of Hadoop than mine, don't worry, just follow along. I'll be using Sublime Text 3. You may use any text editor of your choice. So without wasting any more time, let's start coding. So the first thing you want to do is open up your file explorer and navigate to wherever you want to and create a new folder named word count. Open up your text editor and I will just drag and drop this folder onto it. So this will add this folder as my project. Now within this word count folder I need to have 3 subfolders. So the first one will be source, where our Java files will go, and our next folder will be build, where our compiled class files will go, and finally a dataset folder which will contain the dataset file. Now let's quickly grab our dataset. Now this is the dataset I will be using. So this is the text data of an ebook. So the way you can get this is type in your search bar Gutenberg and visit the first link, that is gutenberg.org. Now this website contains over 56,000 free ebooks, so you can take any ebook of your choice. I will just type in Sherlock Holmes, which I had it open in the other tab, and just choose Return of Sherlock Holmes. And whatever ebook you choose, make sure you click on the plain text format because we only need the text. So Control A or Command A if you are in Mac to select everything in this text file and then copy it, minimize and go to your text editor, and under dataset you want to create a new file and paste all your content. Now I will clean up this file a bit and remove all these extra credits and text at the end and in the beginning, because I only want to have the story, that is the core story, as my input dataset. Let's go back to the front. So the title started from here, so we just remove everything from here till the beginning and save this file using Control S, and I will name this Sherlock Holmes. You can name it anything you like, but make sure that it's .txt as the extension because this is text file. So we have our dataset now. So let's quickly create the 3 Java files we are going to use. The first one, save it as word count mapper.java. This will be our mapper file. Then word count reducer.java. Make sure it's .java is the extension. And this will be word count driver.java. So the first file we are going to work with is our mapper file. So we will start by creating a class named word count mapper. Make sure this is same as the file name, and this will extend mapper from Hadoop and will take in some type parameters. So int writable, just open your braces. Now this mapper contains a function, this parent mapper class contains a function named protected void map function. So this is the function we need to override and implement it in our own way. So this will take in three parameters: long writable key, text value, that is value of type text, and then context of type context. Now you have to handle the exceptions that will be thrown. So it throws two exception, IO exception and interrupted exception. And since you are overriding a parent class, make sure you add @override annotation before the beginning of this function. We don't need the key because it's the byte offset and we don't need it. We only need the value portion, which is the line of text or record that will be passed into map function each time this function is invoked. So we first need to convert this value of type text into string. The way we can do so using .toString method on the value variable, because we can't work with the text data type, so we have to convert it into string data type. Now we have to tokenize or break this line of text into list of words using string tokenizer in Java, and this takes in two parameters, that is the string it needs to tokenize and a list of delimiters mentioned within double quotes. So the first delimiter, let's go back to our dataset file and you will see the list of delimiters. Now a delimiter is a character which separates two consecutive words in your file. So a space is a delimiter, a comma is a delimiter, and so is a full stop, and there are more delimiters if you scan through carefully. So I came up with this list of delimiters, that is space, full stop, comma, question mark, exclamation, then semicolon, colon, opening closing parentheses, opening closing braces, and opening closing square brackets. We also have double quotes as our delimiters. Now this double quote is different from the one which we entered from our keyboard. So I will just grab the double quotes used in the file. So these are actually different. So that's why I'm just copying the opening closing double quotes so that my line of text get tokenized correctly. Now that we have a list of words, we can loop through this list of words using a while loop, and this while loop will execute until it has tokens left in it. Like the list of words has tokens left in it, till then this while loop will run, and token here for us is each word. So the way we can get each word is using the words dot next token method. Now we have to convert each word into a single case, that is, let's go back to a file, and if you see carefully that here the is completely in uppercase, here the is completely in lowercase, here only the T is in uppercase. So all these words will be left as it is and you will get three types of the in your final job output with their respective count. That is not what you want. You want all this the to be treated as a single word, and since your program is case sensitive, so you have to convert all these words either into lowercase or into uppercase to resolve this problem. So I will convert it into lowercase, and two lowercase method will take care of that. Now it's always a good habit to check whether your word is an empty string or not, because if it's an empty string you don't want that as your key. So I will just continue to the next iteration of loop and skip or ignore anything that is written after this if statement. Now if it's not an empty string, then we need to write our output key value pair of mapper using this context.write method, and it takes in two parameters, first one being key and the second one being value. Now key will be the each word we extract. So this word, we can't just simply write word here, we have to convert it to Hadoop data type, which is text, using this new text method, and our value will be 1. We simply can't just write 1 here, we have to convert it into int writable data type, because just 1 is integer data type. So have to convert it into int writable like this, new int writable, and that's all you need to do in your mapper Java file, and we are done with it. So let's quickly import the packages or dependencies we are using in this file up here. This is all we need from Java, and from Hadoop package which starts by org.apache.hadoop. From IO we bring in int writable. Let's copy this and we will bring in long writable, then we will bring in text, and finally from MapReduce we will bring in mapper, because mapper is our superclass here, and this word count mapper is the subclass that we created here. So that's all you need to do. One more import I forgot, that is import Java. From util package you need to bring in string tokenizer. So now we are done with this mapper Java file. So just save this file. One thing I didn't tell you is about this type parameters here. This first two refers to the type parameters of the input key value pair that this mapper takes in, and this last two refers to the output key value pair that this mapper outputs. So here key is the long writable input key, input value is of type text, and and output key is of type text, this text, and this output value is of type int writable. So that is what we mentioned here in type parameters. And let's move on to a reducer file, and again we have to create a new class, word count reducer, same name as file name, and this time instead of inheriting mapper we will inherit reducer, that is extend reducer, and this also will take in type parameters. Text and int, oops, int writable, and just open the braces. Now like mapper, these also have a function, this superclass reducer have a function named protected void reduce, which we need to override and implement it in our own way. So we need to override this reduce function, And so make sure you provide at override annotation up here, and this will take in three parameters. First one being key of type text, the second one will be iterable and within angular braces int writable, then values. So since this is a list of values that reduce function will receive, so list of values means we can iterate through this list of values. So that's why I wrote iterable here. So iterable is the type and each value in the list is of type int writable. So that's why it's mentioned within angular braces like this. And lastly, we need to accept context, and like mapper it will throw IO exception and interrupted exception. So our logic in reducer will be very simple. We know that our list of values will be list of ones, and if we sum up this list of ones, we will get the respective count for each word, and word here is the key that we receive here in this reduce function. So we initialize a variable, declare and initialize a variable named sum. We initialize it to 0, and the way we loop through this list of values is using a for each loop, and the format is the data type of each value, that is int writable, and then the name you want to call that value you extract. So I just name it values, and then the list of values variable. So int writable value in values, so you get each value in each iteration and you just add it to the existing sum variable. Now we just can't simply write value here because value is of type int writable and you can't add int writable and int variable together, so you have to convert it into int data type or integer in Java, and this dot get method will take care of this. And at the end of this for loop, the count will be stored in the sum variable. So all we need to do now is output or write the output key value pair of reducer. Now the reducer output is also the job output, so we write the key first, and our key is each word, and we haven't changed the data type, so we already have the key as text, so we simply pass the key, but we need to write the value which is the sum, and since it is in integer we have to convert it into Hadoop data type using this new int writable. So that's all you need to do in your reducer. Let's quickly bring in our imports up here. IO dot, then from Hadoop we need to bring in conf, we need to bring in configuration, not configuration. From IO we need to bring in int writable, and let's copy this, and from IO we need to bring in text, and then again from MapReduce this time we bring in the reducer that we inherited. So that's all you need to do in the reducer Java file. The logic is as simple as that. We just sum up the value and store it in a variable. That variable will be written as the value portion using this context.write method. So now let's move on to your driver Java file because we are done with reducer. So we start by creating a class again named word count driver, which extends configured and implements an interface named tool. So this will be your entry point for your application program, and so that's why you need to have the main function within this driver file, because this file will be run first before your mapper and reducer. And we will fill in the main data. First we need to override a method named run, which returns integer value. So this run method is available in tool runner, and here in this run method our driver code logic or job configuration and setup will be done. So this takes in the arguments from main function. So we'll pass the arguments, we'll invoke this run method from main function and pass the arguments here, and this throws some exception. I will just throw exception itself because it's a super class and will take care of all the exception it needs to throw. And the first thing we want to do here is check whether the argument received, its length is at least 2. So if args.length is less than 2, then we don't want to continue with our job. We just want to not out, we want to output an error message using system.error.printf, and you can write anything here. So I will just write invalid arguments and append a new line and attach the class name, that is this class name, so that you can understand the error being thrown from this particular driver class. So get class.getName, and we will use the tool runner method named print generic command usage and pass system.error output stream to this function. So this just formats your error output message and displays it on the screen, and we will return a non-zero value. So the value we will return is simply 1. And if we get past this if statement, that means we have at least 2 arguments. So we need to store these 2 arguments. First one we will store in a variable named input.dir, and we will get that from arg0. Remember, array is 0 indexed base. So the first element will be available in arg0, and the first argument will be the path to the input directory in HDFS, and the second argument will be path to the output directory in HDFS, which we will get from args1. So this will be your job input path, and this will be your job output path. So now that we have the job input and output path, so we can create a configuration object, and then we create a new job using the job.getInstance method, and this will take in the config object as one parameter and the job name as another parameter. So we will just give word count as the job name, and now we need to set some parameters here. And the first parameter we need to and the first parameter we need to set is set jar by class. So we will run this three files compiled in a jar file. So we'll compile these three files and then put it in a jar file, and we will run that jar file. So when running the jar file, it will look for an entry point or entry file, the file it needs to run first. So this will be what count driver file that we need to run first, because this have the main function. So that is what we are mentioning here as set jar by class. So your driver file should be mentioned here. So what count driver dot class. So remember, this will be dot class, not dot java. And then we need to set our mapper class. So which class we gonna use as our mapper, and this will be what count mapper dot class that we created earlier. And then we need to set our reducer class. So that will be what count reducer, and again dot class. Now we also need to set the output key class. So what will be the output key class for this job? And this will be text dot class, and your output value class, set output value class, which will be int writable dot class. Now your job output key class or your job output value class will be same as that of the output of reducer. So this text comma int writable, so text being the output key type and int writable being the output value type. So this is what we are mentioning here. Now notice one thing, that your reducer output key value pair type is same, that is text comma int writable. It's same as the mapper output key value pair type. So both are text comma int writable. So that's why we mention only one output key class and value class type here in this job parameter settings. But if you have mapper outputting text comma int writable and reducer outputting something else, say text comma text as output key and output value class, then you have to mention both the output key class and output value class of job and the mapper itself. You have to let Hadoop know that your mapper output type and job output type, that is reducer output type, is different. Next, you need to add your input path, that is job input path. Way we do so is using the file input format dot add input path, and this takes in job as the first parameter and a path object. So we create a path object and we pass in the job input path we stored earlier as input dir. It don't take string as parameter, so you have to convert it into Hadoop type, that is path here, file system type. And next we have to set file output path using this file output format, and this will be set output path, and this will again take in job and a path object. So I will just pass the output dir variable. So that's all we need to do. Now we will just wait for the job to execute and complete. We have set the parameters. Now we just need to wait for the job to execute and complete using this wait for completion, job.wait for completion, and this will return a boolean value. So we store it in a variable named say success, So if your job completes successfully without any errors, your success variable will have a value true. If your job terminates in the middle with some errors and exception, then the success variable will have a value false. So we just need to check if our job completed successfully. If it didn't complete successfully, that is not success, then only this if statement will be executed, and we just throw a exception, new exception, that is new illegal state exception, and just a message. So I will say job word count failed. Now if we get past all these if statements, that is this last if statement, and if we reach this last line, that means everything completed successfully without any errors. So we can simply return 0 now. So let's go back to the main function and invoke this run method. So we first store the value we are returning from this run method into variable named exit code. Then we invoke the method as toolrunner.run, and we run the driver object and pass the arguments we receive in the main function, because it takes in these arguments. Now since this function throws exception, you also need to throw exception or handle this exception in the main. So we just throw exception here, and this run function will return either 0 or a non-zero value, and we can simply do system.exit and write this exit code or pass this variable. So system.exit 0 means your program execution completed successfully without any errors, and system.exit non-zero value means your program completed execution with some errors and exception. So it will just terminate it then and thereby. So that's all we need to do in our word count driver file. Now this is not the only way you can write your driver Java file. There are lots of ways you can write your driver Java file. I just showed you one way to write it. Now let's quickly bring in the imports up here. So from org.apache.hadoop, and then conf, we need to bring in configuration. Let's copy this, paste it. We need to bring in configured, and then from fs we need to bring in path, fs for file system, and then from IO we need to bring in int writable and text, then from MapReduce we bring in job, and then again from MapReduce this time from lib.input we bring in file input format, and MapReduce lib.output, this time we bring in file output format, and then finally from Hadoop util package we bring in tool and tool runner. So that's all we need to do in our word count driver file. So let's save this file. One thing I forgot to tell you, in the reducer Java file, you notice the type of input key value pair we are accepting in reducer. This is matching the output key value type that we are emitting from mapper. So whatever Java MapReduce program you write, MapReduce Java program you write, make sure that this output key value type of mapper matches with the input key value type of reducer. So if you are emitting text comma text from mapper, your reducer type parameter should be mentioned as text comma text for the input key value pair type. So that is one thing I wanted to mention. Let's just compile this file. So go back to the folder or open the folder where you have the word count directory and move into that directory and open a terminal there. So open in terminal and make sure that you are in the word count directory. So if you do ls, you should see these three folders: build, dataset and source. Now the way we compile these Java files is that we have to attach the Hadoop class path to the existing Java class path, because these packages are from Hadoop. These are not from Java library class path. So if we simply do Java C and try to compile this file, our Java library class path won't find these packages and it will give you error. So we have to attach the Hadoop class path where these packages are located. So then you can simply compile all these Java files without any errors. So if we do Hadoop class path, these are all the paths, that is list of paths where your packages are located. Now let's just compile the Java files using Java C, add a -cp flag and then just write $Hadoop class path, cp for class path. That's this $parenthesis Hadoop class path will just evaluate to this entire list of paths, and all these paths will be added to the existing class path. And now we can just compile the Java files, and we wanted our class files to be in this build folder. The way we can mention it is using this -d and the folder name, so build, and our source Java files is within the source folder, src folder, and within this src folder I am just using a wildcard expression, that is asterisk. So this, instead of writing three file names, this will take each and every file available in this source folder and compile it. And now if we do enter, we have an error. So let's just go back to this file. Okay, so I forgot to put a parenthesis here because get class is a method. So let's save this file and try to compile again. So we have the classes compiled and put into the build directory. So let's check into our build directory and we will see the class files available here. So all we need to do now is create the jar file with this class file. So we do so using the jar cvf command, jar cvf, C for creating a jar file, V for verbose output, and F for directing these class files into a single jar file. So we just give a name of the file, so it will be word count.jar. Make sure you put a space between cvf and word count.jar, and then you want to add a -c flag and mention the folder where your class files are located. So build and everything within this build using this dot, and just press enter. So this created a jar file for us, and if we do ls, we can find the jar file word count.jar. So now that we have word count.jar, let's run this jar file using the Hadoop jar command. But before we do that, we need to copy our input dataset file to our HDFS file system. So let's start our Hadoop cluster. Before that, you can also check whether Hadoop is installed or not, and it is installed, and I am using 2.75 version 2.7.5. and if we do hdfs dfs -ls and / to list the directories and file present in hdfs, now I have these folders right now, so I want to create a folder here. So we can do so using hdfs dfs -mkdir and -p, because I want to create a nested folder too. So word -count and / let's say input. So this created a folder for us. Let's quickly check, and we have our word count folder, and within this there should be an input folder. So all we need to do now is copy the file from local file system to HDFS using the HDFS DFS dash, and we can write copy from local. This will work, or even we can write put, which is a simple and shorter version to remember, and then the source path. So go to the dataset folder and drag the file on to your terminal. So this will add the source file path, and then the destination path, which will be / word count destination path in HDFS, remember, / word count, then input. Okay, so there should be a space between DFS and dash put. So let's put a space and run it again, and let's just quickly check whether we have the file in our input directory. So -ls, and we want to look into the directory structure of input. So -ls and the destination folder. So within input we have a file named sherlockholmes.txt, so it's there. Now that we have our input file, that is job input file, copied to HDFS, we can run our jar file. Now if you encountered some error, because it may be because you didn't have your cluster set up, so if all these commands didn't work for you, it may be because your cluster wasn't set up. So if you do jps, you should have this data node, name node, node manager and resource manager running. If you don't see them, then your cluster is shut down, it's not started. So you have to start your cluster, remember, using start dfs.sh, and after that command you again have to do start yarn.sh this time. So these two commands will start your cluster, and then you can just execute this command and your file will be copied to HDFS. So make sure you have your clusters started. I already had my cluster started earlier. So now we can simply do Hadoop jar, and name of jar file, that is word count jar. So make sure you are in the word count folder where you have the jar file, and the entry file name, that is the entry Java file, which is word count driver in our case, because it contains main. And remember, we told that we need to have two arguments, command line arguments. We need to pass two arguments, and the first argument is the path to the dataset, that is input directory path in HDFS, which is / word count / input. So you don't have to mention the file, because it will find the file within this input directory by default, and where you want to output your job. So it should also be an path in HDFS. So word count within this word count and within this output folder. Although this output folder is not there right now, Hadoop will create this output folder and store the output file within this output folder. So Hadoop will take care of that, and just press enter. So our job started, and you can see the number of splits is 1, as we have discussed in the previous video, because it's a small file. It's like 600 or 700 KB, and number of map tasks that will be launched and number of reduce tasks that will be launched should also be 1. So yes, map task and reduce task is 1, and you have your job completed. So the way we can look at the output file is doing hdfs dfs dash cat, and then the file name, that is path to the file. So it should be within word count output, and the file name is like this, part dash r dash, since there will be only one file, so 5 zeros, so 5 zeros. So there you go, each word and their corresponding count is displayed on the screen. This will be a huge list. You can see there are some words that didn't get tokenized well. So here we have single quotes, so we ignored the single quotes as our delimiters, but there was a reason behind it, because you also have words like you would, your, you have. This is a valid single word, so you can consider them as single word. But if you tokenize by single quote, this u and ve will be separated into two words. Now ve is not a valid word, so that there is a problem there. So that's why you have to add in some more logic to tokenize your words for single quotes. And you also have like this double dashes somewhere here, so yes, you also have to take care of that. So you can see that you can improve your logic here and fine tune the mapper code written right now. So we can add in some logic here. After we get the word, we can do further extraction to get the valid word. So you can modify the code and add in your logic, so that is left for you to do. But all I wanted to show is that this is how you run a Java file, that is jar file, in your Hadoop cluster, and this is your output. But if you want to view this output, this is the only way you can view it. You can also view it in your browser. So if you go to localhost 50070 and then go to browse file system, browse the file system. Here you can go into word count and output. Here you have the part dash r dash 50 file. Now it will prompt to download, so you can download this file and view it on your system. You can also take this file from the hdfs file system and copy it to your local file system. The way you do so is using the hdfs dfs and this time dash get. So there is also another command called copy to local, so this will also work, but the shorter version is dash get. Again, the source path should be in hdfs, because you are copying a file from hdfs, and the file name, and then your destination path. I'm just copying it to my home folder. So let's check our home folder, and we have that part R00 file. Now you can view it in your gedit or whatever editor you have in your system. So you see these are all tab space separated, and that's all I wanted to show you in this video. We have coded this word count program and we have run it on the single node cluster. That's it for this video. Hope you like this video and it helped you to get started with MapReduce programming. If you want to see more such video, then stay tuned on this channel because I will produce more such MapReduce programming videos. Till then, stay classy and goodbye.